Hey. Today, as the title suggests, I have not slept very well. I don't know why. I just could not fall asleep. Which is happening to me more and more frequently recently. Maybe because of all the stress. But I have some good news. I have been messaging my physics professor, and he told me that basically anything is allowed during the test, even notebooks. Not like notebooks, like laptops, which is I mean, he's a pretty old guy, so I don't know how well versed he is in AI, but yeah. Let's say that Google Gemini and ChatGPT will get heavily abused during the test. I mean, no. I mean, someone else. Somebody entirely different. To be fair, I think most people will be abusing it, so. But anyhow, let's try to at least somewhat salvage the situation. Get the button away. Get to it. One moment. I need to blow my nose. Okay. Now, my favorite drink. So anyway, since last time I finished conics, today I actually have to start a new topic, and I think it's going to be one of the last. I did like basically all the fucking equations. I did domains. I did now conics, and what's left are matrices, matri. Basically, calculations with matrix. I don't know how you fucking say that. And imaginary numbers. That's also left. Let me just take a quick peek. Ink. So yeah, we got basically like equations. Yeah, and matrices, and systems of linear equations. This also kind of has to do with matrices. Yeah, so let's just get into it. I think I'll just use the official fucking book. I've never had really an issue with like matrices and stuff, so I think this should be like a refresher for me, because I've done all of this in my other university. Yeah, okay. I'm not gonna even write down any theory, because I think it's a waste of time, to be honest. Like I don't want to sound like a vain or something like that, but I have been like, matrices were never a problem for me. I just say like that. Is the Actually, I'm interested. What is the plural of matrix? Matrices. but matrices is also accepted. Okay. Just gonna save it as matrices because English, it can be seen, is not my first language, so yeah. Open selector and Xornal++. Bam. Baggy, so let's do some transpositions. Oh, this is going to be such a pain in the ass, bro. We got the no theory a problems. We got 10-4. Where we have the matrix A equals 1, 0, -7, -5, 2, 1, 3, -3, 2, 3, -3, -2, -2, 1, 3. And we are supposed to find the transposed, not that either, the transposed matrix. Hey, what is it? You just take this and you make it the first row, no? That's how transposition works. I hope so. We've got 1, -5, 3, 2, 0, 2, -3. 1, -7, 1, -2. Is that correct? That is indeed correct. Wow. Oh my god. Right off the bat. Crazy. Ay, 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 ay. Streak is back. Woohoo. Okay. Calm down. Here they're just saying that the matrix individual row can be understood as vectors. You can basically add any row to any other row, which will be then useful in the Gauss's elimination method of solving systems of linear equations. Multiply. And if we have a matrix that has only one row, it's a vector. And if we have a matrix that has only one column, I think, yeah, column, it's a column vector. Okay, blah, blah, blah. Okay. Go to 10-8. You got A, sorry about that. A equals. This is just supposed to be like a little refresher. Let me actually. Is there anything about matrices in my smart little book? Let me check the registry. Is it at the. Let's see. So we got domains, arithmetics, algebra, functions. Ooh, fuck! I forgot about this. Fucking yeah. Probability. Nothing about matrices, really. I guess there's nothing to like. I guess there's nothing to like do there. Not that difficult. No formulas you need to remember. So we got -2, 5, 3, 0, -1, 1, -1, 2. With matrices, it's like important to pay attention. 0, 1, 2, 1, -2, 3, -3, 1, 1, and C, 7, -2, 3, 4, 1, 1, 0, 1, 2, 3, -3. I'm getting messages on my phone. We are supposed to do A plus B. And A plus C. So that's pretty straightforward. It's just pretty much exactly like summing vectors. So you just have to make sure that they have the same dimensions, because you have to sum each element with every other element. So the result A plus B is going to be -2, 6, 5, 1, -3, 4, -4, 3, 3. -2, 1, -4, 6, -3, 3, 5. It's correct. However, I want to actually, fuck, you know. Yeah, so yeah, as I thought. A plus C. Impossible. Not the same, how you call this, resolution? I don't know. 43. Oh my god. Very popular number, that. 43. Let's go next. Okay, so now we are going to do some scalar multiplication. We've got 10, 10. We have the matrix A. -7. The same one. -7. -3. 0, 1, 2, 5, -2. And we are supposed to calculate B -3 times A. That's once again pretty simple. You just take this number and multiply every single element by. That means that B what a save, man. Save the eardrums there. So we get 21 -6, 9, 0, -3, -6, -15, 6, and minus 21 minus 6, 9, 0 minus 6, minus 15, 6. 0 minus 15, 6. That is indeed correct. So these are easy pickings. Easy picking. So I said this is just a little recap. I don't remember exactly how to do everything, but I think if I calculate like 2 or 3 problems, I'll be fine. Wait a second. Wait just a little second, Buster. Oh yeah, I get it now. Okay. Now we get, yeah, as I said, I just need to kind of little refresher. We get matrix multiplication, A, 2, 3, 2, 0, minus 3, 2, 4, minus 1, 1, 1, 1. And we've got B, which is 3, 1, 2, 0, 2, 1. And we are supposed to calculate A times B. So when calculating these multiplications, you just grab the. It's important that this matrix has the same amount of elements in a row as this matrix has in a column. And since this is 3, and this is also 3, it's fine. Because we are going to just do this times this, plus this times this, plus this times this, and this will be this element. Like, I don't know. Let's just do it. Makes more sense. So you got the 2 times 3 is 6, minus 3 is 3, plus 2 is 5. This element is 5. Then we've got, so the final resolution will be 4 elements here and 2 here, I believe. Yeah, 4 times 5, was it? Times 3 minus 3 plus 2. Then we've got 9 plus 2 is 11 plus 2 is 13. 6, then 12 minus 1. 0. You little bozo, okay. 0 minus 6, 5. 0, 4, 5, 0, 8, 9, 0, -2, then 0. That should be the solution now. We are supposed to calculate B times A. Let's check. So it has 2 elements in a row, but this has 4 elements in a column, so it's not possible. It's actually kind of cool because, like, if you have classical numbers, this is just fine, but if you have matrices, this is not the same. So oh, and that is fine. Okay. Mm-hmm. Okay. So we are supposed to calculate the value of a matrix, which actually means the number of the number of rows don't have like 0, 0, 0, 0. So for that, oh, they already kind of did that for us. But we will be doing this soon enough because that the Gauss's elimination method to 5 elements, 1, 2, 3, 4. 0, 0, 0, -5, 2, 0, 0, 0, 3, -3, -2, 0, 0, -2, 1, 3, -1, 0, and 1, 5, 7, 0. So now we just calculate for non-zero rows. On 0 row, which means that the value of the A matrix is 4. Which is correct. I don't even know if I can mark that as correct solution. I do anything, but I only talk about how you can get this into this format, because you will probably never get this like sign. So you can just omit full 0 rows. You can multiply any row by a non-zero number that belongs to the R domain. You can change the order of the rows, and you can add rows to each other. Plus 2 times this row, bang bang, like. Okay, so we have 1022. Value of matrix. You've got the matrix A. 1, 3, minus 2, 2. Yeah, by the way, we care about the non-zero rows because we need like we are looking for how many unique rows there are. And if let's say these two rows are the same, we need to subtract them because they are not unique. That makes sense. I don't know, maybe I'm just talking bullshit. Okay. Obviously, now it would be quite difficult because we want the this format. So let's just look at this. We have a 1 here, which is very convenient. So let's just do minus 2 times this. That yields 1 minus 2, 3. This doesn't change. Then we get a 0 minus 2. So that's plus 4. That's 8. And minus 6 minus 5 is 7. 3, 2, minus 2. Now let's do this. Minus 3 times. Ugh. 1, 2, 3. This doesn't once again change. We get to 0, obviously. 6, 8. And that's minus 11. As we can see, these guys are basically the same. We just do minus 1 times. That was basically what I was talking about before, which yields that A will be equal to 1 minus 2, 3, 0, 8, minus 11. We have can achieve the desired format. Could actually eliminate, like remove that altogether. Wait, that's interesting. If I can just remove this, does this mean that I can just add like because that when we have the multiplication, we care about the number of I guess that doesn't change here. Or maybe it does, because you can, let's say you have a matrix like A, B, C, D. So obviously I can't multiply this, but what if I just add 0, 0? So I want to ask Gemini what my main Gemini thinks about this. I'm such a Gemini fanboy. No, Gemini fanboy. What the fuck? Okay, let's just do this now. Yeah, so the value of sorry about that, which means that the value of a, we have like 2 non-zero one zero row. It means that the value of this matrix is 2. Okay. So we can't do this bullshit when we are multiplying. Okay. Oh yeah, so yep. The fuck? The fuck is M? Oh, is that the number of elements? Okay. So I need to just clarify something. Now we get all these vectors. 6. A 1 minus 2 B 0 1 3 A 2 1 1 and D 3 3 1 minus. I don't know why they are showing me this, because I don't think I ever use this ever. Uh-huh. Mm-hmm. Okay, okay. We want to check whether some of these vectors are redundant just by looking at them. Doesn't seem so, but it's quite difficult to guess. So we do that by just crafting a matrix. Let's call it A 1 2 3 4. 1 0 2 3 2 1 1 3 3 2 minus 2 1 minus 2 3 1 1. Probably once again we'll attempt to get this format, and at the end, if basically the value of the matrix will be 4, that means they are all original, but if we have like 3, it means one of them is at least redundant. So let's calculate that. I guess we can just do this like minus 2x and same times let minus 3x. So that yields 1, 3, minus 2, 0, 1, 2, 3. Then we 0, minus 4 plus 1 will be minus 3, minus 6, minus 2 is minus 8, 4 plus 5, 0, we get minus 6, so we get minus 3. Oi, oi. Okay. Not looking good. Oi, oi, oi. So this means that this one is redundant. So let's do first, let's do minus 1 this to get rid of this, and then let's do minus 3 plus 3x to get rid of this 3, which yields 4, 1, 2, 3, minus 2, 0, 1, 2, 3, and we get 0, 0, 6, so that's minus 2, and this is 9 plus 5 is 14. Then we get 0, 0, 0, 0, which means we have achieved the desirable thing. So the value of a is 3. So I guess that means that one of the curves is 3, and okay. Okay, okay. So now we are looking for the inverse matrix, which you do. First matrix, which you do by, we have this matrix A, solo number. Then you have a couple of different ways to get there, but you want this one, 1, 3, 4, 11. And how you do this is you basically do this. It just means that you get like you get 1, 3, 4, 11, 1, 0, 0. I don't know how you call this motherfucker. And basically you have to add and multiply this motherfucker so that you basically transfer this over, and then what will be left here is the inverse matrix, aka this. Makes any sense. So what can we do? So let's just do minus 3x, so that yields 1 4 1 0. Then we get 0 minus 1. Yeah, minus 12 1 minus 3 1. And now we just do this plus 4 times to get rid of this. So we get 1 0 12 minus 12, so that's 11 4 0 minus 1 minus 1, and then we just multiply 1 to get rid of the 0, which yields 1 0 0 1, and we get minus 11 4 3 minus 1, which means this is basically that the inverse matrix is minus 11 4 3. Oh my god, so cooked. Is that correct? That is indeed correct. Wow. Who would have knew? Ugh. Okay. So now we get like this last big thing when it comes to matrices, matrices, and that's the determinant. To be fair, I don't remember how to do this one, so bear with me. Mm-hmm. Okay. I guess they show like multiple ways how to do it. Well, guys, I'm sorry, I had to take break. I'm fucking cooked. Take a quick 5 and then I'll go for it again because fucking cooked.